HRW98P080. We have a block of granite is pulled up an incline at a constant speed of 2.19 meters per second by a cable and a winch. The indicated distances are, this is D1, this is D2. The coefficient of friction between the block and the incline is 0.4. What is the power due to the force applied by the block to the cable? Okay, notice the only thing that's different in numbers for anybody is the speed here. So I'm going to go with the route. There's actually two things we could do. We could figure out the work done and accelerate it. Really annoying. The easiest way to go is that instantaneous power at any given point is the force times the velocity. I have the velocity right here. All I need to find out is how hard the cable is pulling on the block. For that, we're going to use a free body diagram. So free body diagram of the block. Here's the block. Come on. That's supposed to be the straight line. Sorry if it isn't. Okay, I've got gravity down. I've got the, oops, that was a bad, okay. I've got the force of the cable, I'm just going to call that tension, pulling up the thing. I've got friction pulling down, and I've got the normal force perpendicular to the block. Okay, now I need this angle. I'm going to need this angle. They don't give it to me, but they do give me some distances, so I can figure that out. I've got a triangle where they are telling me that this distance is 40 meters and this distance is 30 meters. Okay, so that angle, I've got the side opposite and the side adjacent. Basically, the tangent of that angle is going to be 3 over 4, 30 over 40. Okay, so if I want the angle, I got to do the inverse tangent of both sides. I end up with angle is the inverse tangent of 30 over 40 or 3 over 4. Okay, if I put that in the calculator, I get that that angle is 36.87. Okay, so I'm gonna need that later. So that's good. Okay, basically I need to find this. And a big ol' hint here, it's being pulled by that constant speed, so the net force should be 0. I'm gonna need more room here. Okie dokie. So, if the net force is 0, then in the y direction, how about orange? The normal force, I'm going to need that to find the friction eventually, so let's go ahead and find normal force first. The normal force should be exactly canceled out by the y component of gravity. So that's going to be mg, it's adjacent to the angle, so cosine of the angle. That is super sloppy. Sorry. So the normal force is going to be equal to mg cosine theta, which means the frictional force will be mu mg. Oop, it froze again. Mg cosine theta. Okie dokie. Then in the x direction, the net force in the x direction needs to equal 0 as well. Well, in the x direction, I've got the cable pulling up the slope, so that's going to be T. And then down the slope, I've got friction. And also down the slope, I've got the x component of gravity. That is across the way from the angle, so that's going to be mg sine theta. Okay, that equals 0. Therefore, what I've got is that the tension, that is the force that the winch is pulling with, is going to have to be, see, add both of these to the other side, it's going to be friction plus mg sine theta. Well, I just found that friction is mu mg cosine theta. So plus mg sine theta, la la la. Okay. And then the power, going back over here, The power, my final answer that I want, is the force of the winch times the velocity. Well, all of this, that's the force of the winch. So the power is going to be mu mg cosine theta plus mg sine theta times v. I know all of those numbers. I've just got to plug them in. I think it's time to go to a smaller pen. Okay, so I have to go back to the problem to see what those were. I've got mu is 0.4, m is 1400 kilograms, g is 9.8 meters per second squared, cosine, got to use that angle that we found before, so 36.87. Wow, I'm still going to run out of room. Plus m g sine theta, sorry, and then that's all times v, which, wow, I'm completely out of room, times 2.19 meters per second. Yuck. Put that all in the calculator and I get, let's see, this is what I get. I get 27643 plus some point stuff. Notice that in the problem, the most they give us is 3 sig figs right here. So really, I shouldn't go beyond that. So really, I should be stopping like here and then rounding from there. And that's why they have 27,700. Okay, that's, they rounded it off. Yeah. Anyway, that's it.